Hello, everyone. I wanted to talk about complexity, complex designs. And here I'm speaking of product design largely. There's a lot of complexity everywhere with which we must contend. But here I'm talking about complex products. And I actually have a little chapter in my updated book, Intense Design. I actually have a chapter called Complexity, which I'm not going to read. Which I've done before, but that would be kind of boring. So, and a little bit about surprise in design, which I've dedicated chapter to as well. But so how do you handle complexity in design? And a funny story to start with is I was reflecting on my decades of design work, and the most technically complicated design I guess I've done was a system to start a diesel engine at a very low temperature. And I designed a really torquey air motor, pneumatic motor, and all kinds of things went with that. It would fly to Nevada a lot and do testing there, and it ended up working well. And it was just complicated, a lot going on with it. And other people have other experiences with complex designs, and I've done other complex designs too, but that's one that came to mind. The humbling thing is that it was never sold. It passed the test, but it was never sold as far as I know. And the whole technology's gone. People don't use air starters really anymore. So it's just a funny and humbling thing. So it's sort of like, okay, what are your credentials to talk about complex design? Well, I've done that. I've done a lot with mechanical systems, using controls and just designing all the little features that are needed as you resolve problems one by one for a lot of different types of systems. And the design I've had that's probably lasted the longest is a real simple design for a natural gas fitting, and it passed the AGA testing, so it's kind of locked in, and I'm not really proud of it, nothing really special about it, but it works, and it worked well, and it's been working for a few decades, so I just think that's a funny story. So complex things don't mean that they make money or that they last a long time or whatever. What benefit was the Gemini program? What do you want to say about that? Or even Apollo or spatial. You can look at these really grand systems and ask, okay, what's the enduring benefit beyond the PR stuff? But anyway, so my thoughts on complex designs are, like, I wrote them out, but I didn't want to read them. So just kind of like some wandering thoughts. One of the things that happens when you deal with resolving a problem that's going to require complexity is stress and being overwhelmed and having this feeling in your gut like, I can't do this. I have no idea how to start. There's so much going on here, I don't know how I can handle it. And I mean, that may sound kind of like an emotional response, but for me it is anyway, because I want to design door stops, I want to design little things that sit on desks, stuff that I know will work, that, terrestrial stuff, there's no issues, and nobody's gonna get hurt. And that's what I want to design in a way, but that's not what professional design is. That's not what challenging design is. And I can tell you from my years of experience with this is the most rewarding designs are the ones that are complicated. And they move into a lot of realms because not only are they complicated, whatever that means, but it turns out you learn every little bit about the design. You designed it, or you've led a team, or been part of the team. And it takes all these layers, and all the layers have to work together to make something work. And what a lot of people don't realize is that you don't just take some engineering drawings and make something and it works. There's something called know-how, and that's I'm not a lawyer. I am like the opposite of a lawyer, but they use it. Well, I've dealt with technology licenses, and you sell patents and know-how. So know-how is the little tricks that make things work. What vendors do you use? What kind of grease do you use? What's the first thing that's most likely to break? What are the weak points? Just all kinds of stuff. Because there's important stuff, there's very important stuff, there's unimportant stuff, and that doesn't show up on drawings or bills of materials and these kind of documents, even though you try hard to do that. So with complex designs, you start, that's, I guess, the rewarding part of it. So this is not, you can't really say, here's how you design complex things, even though that's perhaps the title of this. But it's, I just want to, put up front the emotional side of it too, of being overwhelmed. Then, again, looking at it like a kind of from the top down, the other part is I immediately look at what I've done in the past. That's good and bad. So I think, okay, I've kind of dealt with this problem before, and here's how I handled it. And then the next step is how other people may have handled it. And of course, that's really good because it's like if you're designing a bicycle, you think, I'm going to use 2 wheels. I'm not going to try to break that paradigm because it's been tried and it hasn't worked very well. The flip side, of course, is closing doors, which you don't want to do because maybe there's a great new approach to doing things, and advances in materials are usually what leads the charge on that. So you can get, moly impregnated metals that have built-in lubricity or whatever, and just all kinds of stuff that suddenly it solves a whole series of problems for you. So then, so that's kind of the second part is, okay, I'm looking at my history. What have I done? What have other people done? And then once you get through that, that's kind of the easy part. You go, okay, I'm going to step up to the plate and go at this thing. What I would assert is to kind of oversimplify the taxonomy here, but there's kind of 2 paths. One, you tap into things that do work, and then you also get a prototype as fast as possible for 2 reasons. Now, one is to test your ideas out. Secondly, it really brings the anxiety level down when you get over an initial hurdle. So and that's easier said than done. So there's a lot that goes on before you do a prototype. But and when I talk about the things that work, I have in the book, for example, because it kind of uses Skunk works as a foundation for looking at a lot of things. But the SR-71 used existing cockpit instruments where they could. Why not? And they modified an existing engine, and they used things that you don't redesign ball bearings and shaft seals and things like that. I mean, you use what is out there. And sure, you can do that, but be assured I got a job offer at CRC, Chicago Rawhide Corporation, many years ago as a seal engineer, which I did not take. But there's people that are just spending every ounce of their talent, energy, and ability in creating the perfect shaft seal. And good for them. I'm not going to get into that territory. And that's really neat. It's really, really neat. So, but the second part then is making the prototypes. And of course, we're talking. I have a video that's kind of. I hate to say it's academic, but the whole thing is called "How to Create a Good Idea," which is perhaps a presumptuous title. This is sort of the cousin to that. And there's methods that are used in design to help with creating a good idea. So what I portrayed in that video were these approaches, and the good thing about that is they weren't me; they were the standard of the industry. We'll say, okay, this is one way to do that from. Developing, it's like design thinking or whatever you want, developing empathy, understanding the problem statement, ideation, all this stuff. So after you go through all that, you come up with ideas or concepts, but and there's all these aphorisms, fail frequently, fail often, fail early, but I have to say that's true. Fail in private might be something else too, depending on the culture you're in. Because I failed publicly and I've failed in private, and it's easier to fail in private, being in your garage, than in front of some sales guys. So, but once you get an initial prototype, it gives you something to look at and to work with, and you very, very quickly make the problem real. And that's like the 2 biggest things I would assert is, one, tap into as much existing technology as you can. You might change it later, but grab it and use it. Secondly, get some kind of proof of concept really, really, really fast. It will make a team more energized. And if you sit there with your cups of coffee and sketch pads, you can only go so far. And here I'm talking about complex designs. I'm not talking really about aesthetic elements here, so I'm kind of divorcing those. So this is more mechanistic stuff. And that's the 2 biggest things. But I wanted to continue a little bit with 3D printing because that's really changed working with complex designs. But I guess also with complex designs too, and I write more about this. I don't want to go on too long, but when you have a complex design, it's not simple. So we all love simple solutions. This isn't quite the same, but it comes to mind. There's a story of a truck getting stuck in a tunnel. And I've written about this before in something else, not this book, but and people can't figure out how to get the truck out of the tunnel because it's jammed in there, and they're thinking all these ways. And a little boy comes up and says, "Why don't you let the air out of the tires?" And that was a solution. So we all want simple solutions, and they're great. The KISS principle is very good, true, and you can't argue. I see these. You deal with acoustic treatment, like you see behind me. There's easy ways to do that, and there's hard ways to do that. There's many levels. Some are active. Even the passive ones can have different complexities, and then there's the stuff behind me, which is kind of the simplest type. So simple doesn't mean best at all, and it's what separates, I'll say, professional designers from those with good ideas only, is that we're willing to embrace complexity and just go at it. And then you learn what you need to learn. So the first time I dealt with programmable logic controllers, PLCs, didn't know what I was doing. So I got a PLC and took it home and ended up figuring it out. This was a long time ago. And I turned on the lights in my apartment and turned them on, and I was like, oh, this is cool. It was really interesting. And I really like PLCs because they're really reliable. I mean, super reliable. In all my time, I've only had one fail, and that was, I still don't know why it failed. Something strange happened to it. But anyway, the point is I just learned, you learn what you need to learn. So all the technology are your servants. They're your tools. You bring them in as you need to. And so again, going on with complex designs, what happens though, guaranteed, is when you solve one problem, you'll be presented with more that follow from it, and then more, and then more, and then more, and that's the way it is. The more complex, the more layers of problems that become revealed as you solve another problem, and that can be really discouraging. The solution, there's two. The most likely one is you just hammer through all the problems. The other one is a leapfrog, a whole new direction in approaching the design, and that's wisdom. I mean, sometimes if the roadblocks are so entangled and so complex, you go to plan B, and I've done that. And that's just wisdom. But you don't want to give up early. So again, I know this is kind of like broad, but I've been doing this for a lot of decades. And not that I'm an expert at it, but I've been doing a lot of decades. And the kind of stress and the desire for a simple design all the time, I know what that's like. And I also know what it's like to just work through all that and keep going. And then through that process, you learn all this cool stuff about your design, where it really works well and where it doesn't work so well, and things like that. And it's really why engineers and designers should be in charge of safety for product design, because we know it the best. We know it inside and outside. It's not the marketing guys that know it, it's us. And so I'm a fan of that from a legal standpoint. But I guess that's a digression. So, but I wanted to talk a little bit about 3D printing, because that's really changed things in ways that I didn't anticipate. So I've been involved with 3D printing in some ways for many decades too, because stereolithography was a thing even late 80s. But now, of course, you can print things faster, better. You can actually run you can make production parts, big production parts. And it's really a game changer. And also, even more interesting from a design standpoint, is you have people now, different than my generation, who are designing stuff by trial and error a lot more than we used to be able to get away with, because they can print it out, try it, print it out, try it, and it's just this. That's a new thing. Is that bad? Well, from an old school standpoint, you're thinking, well, you should think about it more and kind of like, do some things before you execute the design. Now it's like, well, I'll try this, hit, print, and boom. But the second thing is, for low volumes, you don't need orthogonal surfaces and easy to machine parts. You can make really complicated forms, and it's free. No big deal. And that's radically new, because even in, not too long ago, for prototyping, you were dealing basically with flat surfaces and that kind of stuff. You didn't do weird geometries and weird curvature right off the bat, and now you can, and it's cheap and easy. And I need to catch up with that too, because I'm kind of, I have a lot of tradition between the gray hairs. So that's really, really interesting. So this makes it a really good time for designers. Use of 3D printing, additive manufacturing, not just in its kind of traditional prototyping format, but as a production tool and even as a trial and error tool. And of course AI layered on that, that's a whole thing too, because now you can do engineering analysis without, little problem from my traditional standpoint, without really understanding engineering. So that's kind of the thing. Now, finally, surprise. So surprise in design, which isn't really related to complex designs, is really precious. So surprise, kind of silly term, I guess, but the unexpected poetry presents words in surprising ways, perhaps. Surprise can be a novel invention, a novel solution. But we really enjoy surprise, and where does it come from, and how do we use it, or do we use it? And so, I don't know if I should go on to that. I'd almost like to read the chapter from that, but I won't, except to say, under the pressure of AI and tradition and referral to experts, surprise is yours. Surprise is coupled with your imagination and creative insights, and it's really a good thing. So surprise, again, doesn't mean strictly novelty. It could mean innovation and just beautiful invention. So I think as technology kind of wraps itself around us in the design world, we still own surprise, and we still own certain things. So go and design complicated things. Just know it's stressful, but you can do it, and you'll be pleased with the labor. And it is labor. Thank you.